Welcome. So what we're going to do is, for this video series, I'm going to show you how to add and subtract rational expressions. And these rational expressions are going to be with polynomials rather than just with some fractions with integers that we've kind of discussed before. So let me just kind of go through some examples. And what I'm going to do is I'm going to go through examples with some numbers, and then you'll kind of see we're going to follow that exact same operation. However, we're going to use some of the techniques that we use for simplifying rational expressions to therefore add and subtract them, or what we sometimes will just call combining them. So let's just go and look at an example here. What if I said I had 1/4 plus 2/4? Let's do 3/4. Let's do 5/4. And then let's look at another example. What if I had 2/3 minus 4/7? Okay? So in these two examples, one I have adding, one I have subtracting. Now, it's very important when adding and subtracting our fractions, or these little rational terms here, we have to make sure our denominators are exactly the same, right? And that's going to be true when we're dealing with rational expressions with polynomials. We're going to have to make sure our denominators are exactly the same. Excuse me. Now, in this case, since we have our denominators exactly the same, we're going to keep our denominator. However, we're going to apply the operation to our numerator. So in this case, I'm adding. So I'm just going to take 1 plus 5, which is 6, and then I leave the denominator 6/4. However, we always need to make sure we simplify our answer and as best we can. And that's going to be true once we get into our polynomials as well. So 6/4, we know that we can reduce that by 2. So I divide the top and the bottom by 2, and I get a final answer of 3/2. So that is going to be my final answer for adding those two fractions. Now, in this case, you can see that my denominators are not the same. So what we have to do is get common denominators. And there's a couple things that we need to remember when getting common denominators. First of all, we need to look at 7 and 3 and determine what is the least common multiple of our two terms, what we call the LCM, or the least common denominator. So we look at 3 and 7 and say, what is the smallest number that both 3 and 7 go into? Well, that number is 21. And a lot of times we'll write that out. The LCM equals 21. Now what we'll do is we need to get both of these fractions so they have an LCM of 21. And to do that, I need to make sure I multiply my denominator, but also my numerator to keep equivalent of fractions. Over here, to get 7 to be 21, I need to multiply by 3. Now, what I mean by equivalent fractions is when now I multiply by 7/7 or 3/3, I get 14/21 minus 12/21. And what I notice is 2/3 is equivalent to 14/21. It's just multiplied by a factor of 7/7. But it's very key because if we reduce 14/21, we're going to get 2/3. If I reduce 12/21, I'm still going to get 4/7. So I'm not changing the fraction's value. All I'm doing is I'm just rewriting it so they have common denominators. Now they have common denominators, I can apply the operation to the numerators. Well, 14 minus 12 is going to be 2/21. Now, in this example, we cannot simplify it, so this is going to be our final answer. All right? So I just wanted to kind of go through a quick little review of adding and subtracting fractions, because we're going to be applying this exact same idea and framework when we get into rational expressions with polynomials. Thanks.